Hi, everybody. I just want to go over this lesson with dissociation and ionization of ions. So, ionic compounds and strong acids and bases will break apart into water when you put them into water. So, with ionic compounds, we call that dissociation, and you can see that here with sodium chloride. And strong acids, you can find on your page 6 of your periodic table, will also break apart. The process is a little bit different, but we'll talk about that when we get to acids and bases. So we got some simple rules. Strong acids like uh, iodic acid, bromic acid, chloric acid, these will break apart, as well as strong bases, which are found at the bottom. Weak acids and ion compounds with low solubility do not break apart, not under normal circumstances anyways. Polyatomic ions don't break apart. You keep them as whole pieces. Covalent compounds do not break apart. And your solubility chart is generally just used for products. And you can see this in your periodic table. So let's take a look at a molecular formula here. So here I have sodium carbonate and iron 2 chloride. It's a double replacement reaction, and we get iron 2 carbonate and 2 sodium chlorides. Since these are all ionic compounds, we're going to break them apart. So first off, why is this a solid? Well, when we look at our periodic table, so when we go to look at our data booklet and our periodic table, we have this solubility chart, okay? So we're looking at iron carbonate. So we have to find carbonate on our list. Here it is down the bottom. And we see that carbonate here, carbonate with anything that is not an alkali ion, hydrogen ion, or ammonium ion, has a low solubility, which means it comes out as a solid. This comes out as a solid. This guy here, though, has sodium. So anything with sodium remains soluble. It is aqueous. So as long as it's aqueous, we're going to break it up. So I broke up the sodium, the carbonate, the iron. I put a 2 in front of the sodium because there's 2 of them. The iron, the chlorine, I broke those up. This I did not because it is a solid, but I broke up the sodium chloride. Now, if it's the same on both sides, here's my lie. If it's the same on both sides, exactly the same, 2 chlorine ions, 2 chlorine ions, 2 sodium ions, 2 sodium ions, I can cancel them out, and my net ionic is what's left over. So this is magnesium hydroxide and hydrochloric acid. This is a acid-base reaction. Works basically the same as a double replacement. I get magnesium chloride and water. Magnesium chloride, if I look at my chart, if I look at chlorine here, only these 3 come out as low solubility. Everything else remains soluble. So this will be aqueous. Water, of course, is a liquid, not aqueous. So once again, I break everything apart, and then I cancel out what is exactly the same on both sides, and my net ionic gives me this. The final one we're going to look at is iron nitrate, potassium thiocyanate, iron 3 nitrate, potassium thiocyanate, this iron 2 thiocyanate ion complex, thiocyanate ion, and potassium nitrate. So once again, I'm going to break everything up that I can. So I can't break up the SCN here because it's not. I can't break up this whole complex here because it is a polyatomic ion. And now I'm going to cancel things out. I have an NO3, an NO3, a K, a K. I have 3 SCNs here, and I have 1 SCN here. I'll cancel one of those out to leave me with 2, and I'll get my final ionic equation. I hope this helps, and I hope you have a great day.